Think back 10 years into your past. Can you remember everything? Now, some things are clearer than others, sure, but there are bound to be some gaps. Like you probably don't remember what you ate for breakfast on February 2nd, 2015, unless something really crazy and memorable seared that day into your memory. Our Earth may have memory problems too. Our 4.5 billion-year-old space rock is missing 1 billion years of its geologic history, nearly a quarter of all that time. How? Let's take a deep dive into the depths of history, farther back than we've maybe ever gone on Nutty History, to figure that out. Deep time. The timescales we're about to discuss here are huge, and so are the destructive forces at play that can maybe explain why there's a billion-year gap in the Earth's history. So let's unpack Earth's history a bit using some visualizations that might just blow your mind. First off, let's look at life on Earth. Let's say we stuck all of Earth's history into one 24-hour party and assume that Earth's history and the party began at midnight. For the first 4 hours, it was chaos, basically just rocks knocking around, meteors crashing and volcanoes erupting and rain accumulating into oceans. Then life would have showed up around 4 a.m. with a bottle of wine. Jellyfish would have come through at around 8:48 that night to dance. Plants made it onto land at around 9:52 and started swaying. Dinosaurs joined at 10:56, and we humans didn't crash the party until 11:58, just before midnight, just before the whole thing was broken up by the police. Let's put human history into perspective. Imagine going for a walk. Each step is 100 years back. The first step you take takes you back to just after World War I. The Ottoman Empire has just collapsed. Most of the world is dark at night because electricity just became a thing. Take 20 more steps and you're in the Roman Empire. Take around 70 more and you're in the last ice age. There are woolly mammoths and sea levels are 400 feet lower. You've gone pretty far back in human history, and you've only gone a fraction of a mile so far, and maybe you're thinking, okay, not so much farther to get to the dinosaurs, maybe a couple more miles to when the oceans were forming, etc. But no, it would take you walking 20 miles a day for 4 years to get to the beginning of Earth's history. Then think about the temporary nature of it all. 99.9% of all the life that has ever existed on Earth is now extinct. There have been 5 mass extinction events that we know of for sure, where at least 75% of all life on Earth vanished. During one of those, called the Permian-Triassic extinction event, which occurred around 250 million years ago, 96% of all life died. It's been dubbed the Great Dying. The leading culprit for this massive loss of life is thought to be volcanoes that erupted in Siberia for hundreds of thousands of years, spewing over 3 million cubic kilometers of ash into the atmosphere. That's enough to cover the entire United States in 1,000 feet of ash. There was acid rain, forests burned to the ground. It was chaos. And there could have been an even worse extinction event. And the clues might be in the rocks. Strange rocks. Geologists can figure out the eras in Earth's history by looking at the layers of sediment that have been accumulating since the beginning. Sedimentation is basically a process of erosion and compaction that creates distinct layers in the Earth's crust. Different types of rocks represent distinct chapters that chronicle various eras and locations. For instance, when examining sandstone, it's like reading a chapter about ancient deserts. Exploring limestone reveals stories of primordial oceans teeming with life. Sedimentary clues are also recorded in these rocks. They give us hints about ancient environmental conditions like the gentle movements of water or the sweeping force of wind, or a massive series of volcanic eruptions that lasted for millennia. Usually, these sediments are deposited and then compacted in ways to make it easy-ish for people who study this kind of stuff to figure out Earth's distant past. Usually. But in 1787, when geologist James Hutton was walking near some cliffs in Sicker Point in Scotland, he noticed something unusual. There was a pretty striking difference between the lower rock formation of one cliff, which was made up of grayish deep-sea deposits, and the reddish upper formation deposited more recently by rivers and streams. These different formations had a clear line of demarcation, called an unconformity by geologists. It indicated major change over time with a gap in the geological record in between layers. The deep-sea deposits that made up the lower grayish rock layer ended up dating back to about 425 million years ago to the Silurian period. The reddish upper river deposits, though, were from about 345 million years ago during the Carboniferous period. 80 million years were just missing in that cliff. The anomaly was dubbed Hutton's unconformity. It wouldn't be long before more started popping up that were even more head-scratching. Now let us know in the comments your theories on that. The Great Unconformity. An American geologist named John Wesley Powell discovered a magnificent and crazy mysterious gap in the geological record. In 1869, Powell led an expedition through the Grand Canyon. Now, this was peak Wild West times, and the expedition was dangerous. During his treacherous 3-month journey down the Colorado River, Powell noticed another strange unconformity in the rocks. Older rocks were tilted and eroded before younger sedimentary layers were deposited on top, and this time the gap was even larger. The vertical rocks were later dated to the 525 million-year-old Cambrian period, but the horizontal rocks below were staggeringly older, 1.7 billion years old from the Precambrian era. This left a jaw-dropping gap of over 1.2 billion years of missing geology sandwiched between the two neatly stacked layers. It was later named Powell's Great Unconformity, Powell because of the guy who discovered it, and great because of the huge time scale of missing geological history. It's since been proven to span the entirety of North America, or Laurentia, which is the ancient core of the continent, and it wasn't found only in North America. There have been other unconformities found all over the world that date to around the same time. The Mount Isa Gap unconformity in Australia covers about the same time period as Powell's, with a gap that could be even longer, 1.6 billion years. There's another in Brazil's Parana Basin that has a top layer that's around the same age as the top layer in the Grand Canyon's unconformity, 500 million years old. But the gap between that and the lower layer, which is 800 million years old, is only 300 million years. Only, which is a relatively short time in these geological sagas. Snowball Earth, a theory you've never heard of. How do geologists account for all this missing time? I mean, what the heck happened between 500 million and 1.7 billion years ago? The answer, maybe, is a snowball. There's a theory called Snowball Earth. And according to the theory, around 650 million years ago, there was an ice age so extreme that both of Earth's poles froze over, expanded towards the equator, and completely covered the planet with miles of glaciers and ice sheets. From space, our pale blue dot would have looked like a pure white snowball. These massive ice flows were capable of massive erosional forces. They ground away at the land surface below as they moved around. Estimates are that they could have collectively removed an astonishing 2 to 3 miles in depth of surface rock globally by this abrasive grinding over a long period during the so-called cryogenian period when this might have occurred. This mass erosion might be the reason we're missing such a huge amount of time in the geological record. Eons of geology was simply scraped and gouged away, ending up at the bottom of Earth's ancient oceans. The Cambrian explosion. The theory also explains something called the Cambrian explosion. All these ground-up rocks sinking down into the oceans gave vital minerals to the tiny amount of bacterial life that managed to survive Snowball Earth deep down near volcanic events and things like that. It was like supercharged fertilizer. As a result, life exploded in a way that it never had before. Before, only very simple life forms existed: bacteria, small multicellular organisms. Nothing that was much bigger than a few centimeters, and that was pushing it. After, well, things took off under the sea. Basically, all complex life as we know it developed during the Cambrian period in the oceans. The world's oldest jellyfish popped up around then, as different types of mollusks and crustaceans. What else do you think developed in this period? Not so fast. So does this mean that maybe there were all kinds of other animals living on the planet that were wiped out and disappeared from the fossil record that we may never know about? One guy who did a lot of work on the Grand Canyon's Great Unconformity tried to make the case for it, but his ideas never really held water. We'll get to him in a second. First, though, let's look at how unconformed the Great Unconformity really is. We should really say Great Unconformities when we're talking about this kind of stuff. Despite its significance, it's important to realize that the Great Unconformity is not a universal geological feature, meaning it is not found everywhere in the world. This is because the existence of the Great Unconformity doesn't imply the complete absence of Precambrian strata or fossils from the geological record. In some places, the unconformity might be present, while in others, Precambrian strata and fossils are preserved. And there's other unconformities from different geological epochs all over the world. Another unconformity in Wyoming was discovered that's been dated to 700 or 800 million years ago, several hundred years older than the top layer of Powell's Great Unconformity in the Grand Canyon. There are also younger unconformities. The diamictite layers in South Africa are much younger, where a top layer had been dated to around 250 million years, and an underlying unconformity representing a missing 700 million years, probably from a different glaciation event. Let's get back to the idea that a whole lot of prehistoric life disappeared from the fossil record during this proposed Snowball Earth event. One of the guys who thought this was the case was Charles Doolittle Walcott. He did a ton of work on the Grand Canyon's great unconformity in the late 19th and early 20th centuries and helped push the discovery into the realm of accepted geological science. But he also hated on the Cambrian explosion. He thought that there may have well been more complex Precambrian life that we just couldn't find. He proposed something called the Lipalian interval, hypothesizing that sedimentation conditions were not just right for preserving fossils. The Snowball Earth theory hadn't been proposed yet, but if it had, he probably would have added it to his hypothesis. Unfortunately for Walcott, his idea was rejected. There have been other sites where Precambrian fossils were found, but there remains one more mystery: the Precambrian life, which was mostly small worm-like things floating around in the water. But these weird things have no modern counterparts. There is a gap in the evolutionary record between Precambrian life and life after the Cambrian explosion that scientists haven't been able to figure out. Can the great unconformity in Snowball Earth help us figure it out? Or will we be left in the dark by the massive, destructive, yet life-giving forces of our miraculous planet? Thanks for watching. What other deep history questions do you have? Let us know in the comments, and don't forget to like and subscribe for more nutty history.